Example 1. Evaluate the exact value of sine of 7 pi over 12. So anytime we have these pi over 12 angles, we need to be able to express these as a sum or difference of the special angles. And it's important to note that it says exact value, so we must be dealing with special value angles. But 7 pi over 12 is not a special value angle itself, but it can be generated by a combination of adding or subtracting special angles. For example, 7 pi over 12 can be expressed as pi over 4 plus pi over 3. So that ends up being 3 pi over 12 plus 4 pi over 12, which gives us 7 pi over 12. We can also get 7 pi over 12 by taking 3 pi over 4 and subtracting pi over 6. So 3 pi over 4 with common denominator is going to be 9 pi over 12. And then minus 2 pi over 12 is going to give us the 7 pi over 12 that we're looking for. So there's many combinations that will get us there. So we're going to choose, in this case here, I'm going to choose, in this case, 4 pi plus, pi over 4 plus pi over 3. So I'm going to use pi over 4. I'm going to do this in blue, pi over 4 plus pi over 3. Okay, so I've got pi over 4 over here and pi over 3 pictures over here. So then once I see a plus, before I do any of the circle trig, I'm going to just write out the formula. From my formula sheet, anytime I see a plus, I need to go straight to my formula sheet. It's going to be sine of, I'll just color code this here. It's going to be sine of pi over 4 cosine of pi over 3 plus, we switch it around, it's going to be sine of pi over 3 and then cosine of pi over 4. Okay, so that's the first thing I'm going to do. The thing I need to make sure I watch out for is, you may know what sine of pi over 4 is. If I take a look at this picture, sine of pi over 4 is going to be vertical over the radius. So the picture in blue, so it's going to be 1 over root 2. What you never want to do is write something like this, sine and then 1 over root 2. Okay, this is immediately wrong. You'll get marks taken off as soon as I see anything like that on your page, because this makes absolutely no sense. Because when we talk about sine is a ratio. 1 over root 2 is a ratio. You cannot take the sine of a ratio. We take the sine of the angle pi over 4. The answer is going to be 1 over root 2. So we're never going to write this down. If I want to write this, what I do is I replace sine of pi over 4 with the ratio 1 over root 2. So what ends up happening then is I replace sine of pi over 4, not the pi over 4, but the whole thing, with 1 over root 2. Same thing with cos. I go to the root pi over 3, and I want the cosine value. It's going to be 1 divided by 2. So then I replace the cosine with 1 divided by 2. We do not write cosine 1/2 like this. This is wrong. Okay, the 1/2 is the cosine value. So replace the whole cosine with the value 1/2. Plus, sine of pi over 3, I need to go to the pi over 3 picture. Sine of pi over 3 is going to be root 3 over 2. So then I have root 3 over 2. I replace the whole sine pi over 3 with root 3 over 2. Okay, I do not put root 3 over 2 inside a sine expression. And cosine pi over 4, cosine is going to be the horizontal over the radius, so 1 over root 2. Okay, so there it is. I've got my sine value for 7 pi over 4. It's an exact value. All I need to do is simplify this expression, so I end up with 1 over 2 root 2. root 3 over 2 root 2. Now, usually what will happen using this formula is we'll get a common denominator. So we end up with 1 plus root 3 in the numerator over 2 root 2 in the denominator. And this is my answer. So the sign value of 7 pi over 12 is 1 plus root 3 over 2 root 2. So I've kind of drawn this picture over here. 7 pi over 12, the sign values, that vertical value to that point, this point right here, is going to be 1 plus root 3 over 2 root 2 is going to be the vertical distance in this. Okay, so that length to the vertical distance to that x-axis. Okay, so we could do the same thing for cosine 13 pi over 12. There's many different ways to get 13 pi over 12, but it has to be some combination of the special angles pi over 4, pi over 3, or pi over 6. So in this case here, we're going to use the subtraction because in the last one we used an addition formula. I'm going to use a subtraction. So I'm going to do cosine, and I'm going to break this down into 15 pi over 12 minus 2 pi over 12. Okay, so this works out to be cosine of 15 pi over 12. We're going to write as, I forgot which colors I use here. I just want to make sure I use the same colors. I didn't do this here, did I? Okay, so 15 pi over 12, I'm going to do in blue. That simplifies to divide by 3, so I get 5 pi over 4. And then we're going to minus 2 pi over 12 simplifies to pi over 6. Okay, so I've got my two special angles that get me to 13 pi over 12. I'm now going to put it into my formula. For cosine, it's going to be cos cos. So cosine 5 pi over 4. It's going to be cosine of pi over 6. For minus, it's plus in between, and then it's going to be sine of 5 pi over 4, sine of pi over 6. Okay, so I need a picture for those two angles, so I'm going to draw one here. So for 5 pi over 6, draw that a little bit better. 5 pi over 4, we're going to be down here. This angle here is going to give us the 5 pi over 4. And so we're going to end up with -1, -1, root 2. It's in quadrant 3. So this cosine value is going to be -1 over root 2. For pi over 6, I'm going to draw a picture for pi over 6. Okay, pi over 6 is in quadrant 1. It's over here. It's going to be 1, 2, root 3. So that's going to be for pi over 6. So cosine pi over 6 is going to be the long side root 3 over 2 plus sine of 5 pi over 4, -1 over root 2. Sine of pi over 6 is going to be 1/2. And there I have the exact values to get cosine 13 pi over 12. I can simplify this. This becomes -√3 minus 1. That's all over 2 root 2. Okay, so there's my answer. So when I talk about any angles of pi over 12, really what ends up happening is this is going to be in this circle, and it's going to be in those positions on the circle. And if you notice that those positions all have the same triangle, the same reference triangle. And those side lengths are either going to be, in this case here, this is going to be, that short side is going to be 1 minus root 3. So it's going to be root 3 minus 1. Okay, root 3 minus 1 over 2 root 2. The long side is going to be root 3 plus 1 over 2 root 2. And we have all variations of that because we could be in the negative or positive direction. So we can generalize every single one of these answers are going to end up being, I'm just going to generalize this, the answers to all these Part 12 questions should be a length of plus minus root 3 plus minus 1 over 2 root 2. And that will give us all the different positions on the circle where the green angles lie. Okay, so if you remember this, a good double check is that see if you did it correctly. Your answers have to be have a root 3 and 1 in the numerator and a 2 root 2 in the denominator.